Welcome back to our series. In the last part, we built the individual front-end components for our game's main screen. Today, we are going to put all those pieces together. We'll start by creating the final UI elements, the toast notifications, and the main navigation bar. Then we'll assemble everything in our main page.tsx file, implement the crucial client-side authentication flow, and finally, we'll build the robust rate limiting system that will protect our entire backend. Let's get started. First, I'll create a simple but essential component for user feedback, toast.tsx. This is a straightforward React component. It takes a message, a show boolean, and an unhide function as props. Using a useEffect hook, it sets a 3-second timer whenever it's shown. After the timer completes, it calls the unhide function to remove itself from the screen. The styling uses our custom classes to create a clean floating notification that will give the user clear feedback for actions like copying a link or claiming a bonus. Next, we'll build the navigation system for our app, the bottom nav.tsx component. This component is the backbone of our app's navigation. It defines an array of navigation items, each with an ID, label, and a font awesome icon. It then maps over this array to render each button. The currently active page is highlighted using styles determined by the current page prop. Notice the pattern bottom style. It uses inf save area inset bottom, which is a critical CSS function for mobile design. It ensures our navigation bar doesn't get obscured by the home bar on modern iPhones. I've also added some simple on-mouse down and on-touch start events, so give the buttons a satisfying press down effect, enhancing the user experience. Now it's time to assemble these pieces. I'll create a new component called mainSection.tsx. This will act as a container for all the elements in our home screen. This component is purely for organization. It doesn't have its own logic. It simply takes the user data and callback functions as props and arranges the user info, play button, and daily bonus components that we built in the last video. This keeps our main page file clean and readable. And now we'll bring it all together in our root app/page.tsx. I'm going to replace the default Next.js boilerplate with the final code for our homepage. This file is the main controller for our frontend. Let's walk through it carefully. State management. At the top, we define several state variables using useState. We track the user object, the current page for navigation, a loading state, the user's points, and the state for our toast notification. The initApp function. This is the heart of our client-side logic. It's wrapped in a useEffect hook, so it runs as soon as the component mounts. It first initializes the Telegram Web App SDK and tells the Telegram client that our app is ready and should be expanded to the full screen. It then grabs the init data string provided by Telegram. Using our API client, it makes a POST request to our backend at /API/auth/Telegram, sending this init data. If the backend successfully validates the data and finds or creates the user, it sends the user object back. We then update our user and point state with the data from the server, and the loading state is set to false. We also check if the user is new. If so, we show a friendly welcome toast. Conditional rendering. The return statement uses this state to render the UI. If it's loading, it shows a spinner. If no user data is found, meaning the app is opened outside of Telegram, it displays a helpful message with a link to open the app correctly. Component composition. Once the user is loaded, it renders our main layout. It displays the correct page, main section or other, based on the current page state. It also renders the bottom nav, passing it the set current page function so it can control the navigation state, and the toast component ready to display messages. With the front-end logic in place, let's build the backend infrastructure to protect it. A production app needs robust rate limiting. I'll create a new utility file at lib/utils/rate-limit.ts. This is a professional-grade rate limiting setup using Upstash Redis. Initialization. It connects to our Upstash Redis instance, but is designed to fail gracefully. If the environment variables aren't set, it simply disables rate limiting and logs a warning. Rate limiters object. This is the key part. We create a unique named rate limiter for every single API endpoint. This gives us granular control. For example, we can allow many requests to the leaderboard, but be much stricter with game start or payment endpoints. Suspicious user system. We have two functions: check and flag suspicious user and is suspicious user. If our game logic detects cheating, for example, a user trying to submit an impossibly high score, we can flag their user ID in Redis. Get appropriate limiter. This function is very clever. Before applying a rate limit, it checks if the user has been flagged as suspicious. If they have, it ignores the default limiter and applies a much stricter one, effectively throttling any potential bad actor without affecting legitimate users. With rate limit wrapper. This is a helper function we'll use in our API routes to easily apply this logic. To add another layer of protection, we'll use Next.js middleware for global API-based rate limiting. I'll create a middleware.ts file at the root of the project. This middleware runs on the edge for every incoming API request before it even hits our serverless function. It applies a very generous rate limit based on the user's IP address. This isn't meant to stop individual users, but to provide a first line of defense against large-scale automated attacks or DDoS attempts. It also includes an important exception to bypass this check for our authenticated Telegram webhook, since those requests all come from Telegram servers. Finally, let's create the API endpoint that our frontend calls to authenticate the user. app/api/auth/telegram/route.ts. This router is the backend counterpart to the init app function we wrote earlier. Verify Telegram web app data. This is the most critical security function. It takes the init data stream from the client and performs an HMAC cryptographic check using our secret Telegram bot token. This mathematically proves that the data is authentic and has not been tampered with. Post handler. The main function first validates the init data. It then applies our new rate limiter. Database logic. The core of the function is a database transaction. It uses a single atomic insert on conflict do nothing command. This is a highly efficient way to handle user creation. If the user's Telegram ID already exists, it does nothing. If it doesn't, it creates a new user record. Referral logic. Inside this same atomic transaction, if a new user is created and they came from a referral link, the code also updates the referrer's points and referral count. Putting this inside the transaction guarantees that the new user and the referral bonus are applied together or not at all, preventing any database inconsistencies. Now let's see the result of all our hard work. I'll refresh the app inside Telegram. It loads our init app function fires, it authenticates with our new API endpoint, and there it is. Our main screen is fully rendered, with live data from the database. You can see my user info, my current level, and my stats. All the components we've built are now working together. In our next videos, we'll build out the remaining pages of our application, the referral screen, the leaderboard, and the wallet connection page. I'll see you then.